Hey guys, I'm just going to run through two examples that seem to come up all the time with trigonometry. I was correcting your homework there and you all did really well, so keep up the good work. Okay, so the first scenario that seems to always come up is when the angle is unknown. There's a letter in here, or it could be up here. A letter A, B, or X. So no matter what, when you're asked a question like this, you should all be writing your SOHCAHTOA. You'll see that in my solutions when I put them up, that I've that written down for every question. Your next step then is to label your triangle. So 7 is opposite x, so 7 is the opposite. And 3 is beside the x, so 3 is the adjacent. The hypotenuse is always the one across from the right angle. That's our hypotenuse. It is not in use in this question. So always label your triangle first. Next step then is decide which one we're going to use, sine, cos, or tan. So we have opposite and adjacent. So it's not going to be sine because we're not using the hypotenuse. It's not going to be cos because again that needs the hypotenuse. It's going to be tan because tan uses opposite and adjacent. So the angle that we're working with is x, so we'll say tan x equals, and we know that that equals opposite over adjacent, meaning 7 over 3. Okay? Next thing then is we're trying to find this angle. So we cannot write into our calculators tan x. It'll give you back an error. So we have to work backwards. We need to put this fraction in here. And the way we work backwards is we use the inverse function. And the inverse function, the backwards function, is on your calculators you press shift and then we're working with tan, and you'll see there then the -1 comes up. And then you just use your fraction and we'll say 7 over 3, close your brackets, close your brackets, equals, okay, 66.8 degrees. Now also lads, you need to double check, are they asking for one decimal place, are they asking to the nearest degree? So say for example I want it to the nearest degree, then x equals 67, because that 8 is over 5 and it brings that 6 up. Okay, so when the angle is unknown, you label the triangle, the sides of the triangle. You decide which one you're going to use, sine, cos, or tan. And because the angle is unknown, we use the inverse function. We go backwards and put in the fraction beside tan. Okay, so I just squeeze that in here. That should say 7 over 3. Okay, hope that helps, guys. And I'll just show you the other scenario then here. Okay, another right angle triangle. And this time the angle is known. It's given to us. It's 51 degrees. But we have an unknown side. So again, always first things first, SOHCAHTOA. Next thing, labels. The 11 is opposite the right angle, so it must be the hypotenuse. And the x is beside 51, so it must be the adjacent. We're not working with that side at all today, it's blank. So labels, I'll just write it down again. You must label it. Next step then is decide, are we going to use sine, cos, or tan? Will we use sine? Do we have opposite and hypotenuse? No. Will we use cos? Do we have adjacent and hypotenuse? We do. So we're going to use cos. And what angle? This time it is known. It is 51. And that equals adjacent, which is x, over hypotenuse, which is 11. Now this time we don't need to use the inverse function because we have the angle. We can type in cos 51 into our calculators. And there we go. And I'm going to say I want it to 3 decimal places. So we have 0.629 is equal to 11, or x over 11. So we have just changed cos 51 into a decimal using our calculators. We need to find x on its own. So that 11 is bothering us here, we need to move it. So when we bring it over, it multiplies. When you bring it across the equal to sign, it's going to multiply. So brackets mean multiply. And into your calculators, 11 multiplied by 0.629 equals 6.919. And say I want it to 1 decimal place, that is 6.9 equals x. Okay, so in this scenario we were finding an unknown side given the angle. So all that was new is we need to multiply across when we have a fraction like that. Hope that helps, guys.